everyone. This note is on proving trig identities, and this is day 2 of our lessons right here. So let's go ahead and try it. In question number 1, we're asked to prove the following identities. But before we do that, I just want to bring your attention to some suggestions before we actually go ahead and start this question. So if you remember, we have to write equivalent statements and don't change the statements, okay? So we're not going to do any type of operation that is not just multiplying by 1, okay? You have to keep everything on its own side. So everything on the left side stays on the left side, everything on the right side stays on the right side. It's a strong suggestion to change all ratios to sine and cosine. It's not necessarily always going to be helpful, but quite often it will be helpful. Make sure to follow all number and algebra rules. The double angle formulas and addition and subtraction formulas, don't worry about that right now, but the Pythagorean identities are very important. So remember sine squared plus cosine squared equals 1, and all the other identities that come from that derive from that. Use the conjugate as complex conjugate, but it should just be use the conjugate and then try to factor if possible. Okay. So let's take a look at this right here. Our goal is to get the left side to look like the right side. Sometimes we're going to do everything to the left side. We're going to manipulate the left side, not manipulate it, but like rewrite it in an equivalent way. Sometimes we're going to rewrite the right side. Sometimes we're going to do a little bit of both until we get to a point where they're both going to be the same. Okay, so I'm actually going to take the left side here. So the left side of this right here is saying sine of x plus cosine of x. And I'm going to square that. So according to some of the algebra rules we know that if you square a binomial, you're just going to do sine x plus cosine x times sine of x plus cosine of x. And now we're going to FOIL this, okay? We're going to expand this. So when I multiply sine x by sine x, I get sine squared x. Sine x times cosine x is sine x cosine x. Cosine x times sine x is cosine x sine x. And then cosine x times cosine x is cosine squared x. Now I'm going to rearrange this right here. I'm going to put sine squared x and cosine squared x next to each other. Why would I do that? Because those two together make a Pythagorean identity. And then if you notice right here, I have sine x, cosine x, sine x. These are like terms, they're just in a different order. So because I have one of them here and one of them here, I have 2 sine x, cosine x. Also, if you're just comfortable with expanding a binomial squared, you should know that it should be a squared plus 2ab plus b squared, right? If this is a and this is b. Okay, so then we know that sine squared plus cosine squared x is 1. And then we're just going to copy down this plus 2 sine x cosine x. And look at that. The right side says 1 plus 2 sine x cosine x. So now we can just say right here, left side equals right side. Boom, done. So we can put a check, we can put a box, we can make a smiley face. I mean, that's not really mathematical, but go for it because it's exciting that you have shown this identity is true. So for question number 1, I'm going to take the left side and I'm going to see what I can do with this right here. So first thing I'm going to do is I'm going to rewrite this in terms of cosine. And if you notice right here, we have 2 different expressions, but one's a fraction, one isn't. So right here, I'm just going to put a little star right here. And one of my suggestions to you is to find a common denominator, find a least common denominator. Okay, so if I were to look at this right here, I would make this over 1, and my least common denominator would be cosine to the power of 4x. So my first fraction that I see here, I don't have to multiply it by anything, but the second fraction I have to multiply numerator and denominator by cos to the power of 4. So I end up getting right here that this is equal to 1 over cos to the power of 4x
minus cos to the power of 4x over cos to the power of 4x. And then I can just put this together into a single fraction. So 1 minus cosine to the power of 4x all over cosine to the power of 4x. Remember, keep this left side right here in mind as you are going through your work that you're doing here. Now, another strategy or another little tip that's going to be helpful to you is when I take a look at this right here, I can see that I can't really do anything else within my fraction here. Like I can't simplify anything further. I can't put anything together. So another thing that I would try to do is factor as much as possible. Any factoring I can do will be good. So if you take a look at this numerator here, this is a difference of perfect squares. I have two terms. I have subtraction. I can square root 1, and I can square root x cosine x to the power of 4, cosine to the power of 4x. So because it's a difference of perfect squares, I can write this out as 1 minus cosine squared x and 1 plus cosine squared x. And that's all over cosine to the power of 4x. Now, when we get here, we should see that this right here is familiar to us because we can move the cosine squared over, so we get 1 minus cosine squared x, and that's what sine squared x is. So here I can replace 1 minus cosine squared x with sine squared x. So it's going to be sine squared x times 1 plus cosine squared x all over cosine to the power of 4x. And I'm now going to take a look at my right side of my equation right here. So this is really all I want to do with the left side. For my right side right here, I know that it is sine squared x plus sine squared x cosine squared x all over cosine to the power of 4x. And again, I want to work back and forth and see what I can find out that's in common. So right here, getting this common denominator of cosine to the power of 4x was a really good idea because I already have that on the right side. Now, again, I want to factor as much as possible. So if you take a look on this side right here, there is a sine squared x in common. So I can factor out that sine squared x. In my first term right here, I would end up getting a 1. And when I factored out of here, I would end up getting cosine squared x. And that's all over cosine to the power of 4x, which is exactly what we've been able to write our left-hand side as. So that means that our left side equals our right side. And so we have proven our identity right here. Another option I have is I could have just distributed the sine squared through and then just left the right side as is. It's up to you, whatever you prefer, as long as you understand what it is that you're doing. All right, in our last example here, we've got our left side and our right side. Let's start with our left side because we've got tan and cotan, and I just want to rewrite this using sine and cosine. And right here, I have two different fractions. So again, I'm going to try to get a common denominator. And my least common denominator this time is cosine squared x times sine squared x, which is pretty promising because that's the exact same denominator that we have in on the right-hand side. So this fraction on the left side is missing sine squared x. So I'll multiply numerator and denominator by sine squared x. This side over here is missing cosine squared x. So I'm going to multiply numerator and denominator by cosine squared x. And so this whole thing right here turns into sine to the power of 4x minus cosine to the power of 4x all over cosine squared x, sine squared x. So I got sine to the power of 4x by multiplying sine squared times sine squared. I got cosine to the power of 4x by multiplying cosine squared by cosine squared. All right, cool. Now, there's not really a whole lot more that I can do with this. And if I go back and I look at all my identities that I have here, there's nothing about anything to the power of 4. So this isn't going to be helpful to me yet to use my identities. So what are some other things that we have done in the past? We said find an LCD, which we've done, but factoring is going to be really helpful as well. So right here, I'm going to factor. How do I know I can factor? Because when I look at this right here, I see a difference of perfect squares. I see two terms, I see subtraction, and I see expressions that are perfect squares. So I'm going to factor my numerator right here. So I end up getting, I know that it's, first of all, I'm going to have brackets here. And I want sine squared x and sine squared x because that gives me sine to the power of 4. And then I want cosine squared x and cosine squared x because that would give me cosine to the power of 4. And one's a plus and one is a minus. And then I'm just going to copy down this numerator of cosine squared x, sine squared x. Okay? And now I can look back and see this identity right here, sine squared x plus cosine squared x, is the same thing as 1. So I can replace this entire expression with the number 1. It's super nice because it literally is just going to make everything inside of there disappear. Because when I multiply anything by 1, it keeps the number exactly the same. And this is going to be all over cosine squared x, sine squared x. So then right here, I end up getting, I don't really need to put the 1 there. So I end up getting sine squared x minus cosine squared x all over cosine squared x, sine squared x. Again, keep in mind that we are trying to show right-hand side equals left-hand side. So every time I'm going through this, I want to work back and forth between the two. However, the right side is literally this. This is the right-hand side. So therefore, the left side equals the right side. I've proven my identity, so my proof is completed. And we are all done with this trig proof. Okay, in this last example, this one's really tricky, but I want to show you this example for 2 reasons. Number 1, in the previous examples, we either completely changed the left side until it matched the right side, or we completely changed the right side until it matched the left side. But in this example, we're going to have to do a little bit of changing on both sides until we get to 2 equivalent expressions. And then we're also going to talk about the conjugate in this question. So on the left side of my equation right here, I've got 1 over cosecant of x minus cotangent of x. On this left side right here, I am going to rewrite everything in terms of sine and cosine. So cosecant of x is 1 over sine of x, and cotangent of x is cosine of x over sine of x. Now, what I'm going to do next is I don't like the fact that I have fractions within fractions. I don't like these complex fractions. So I'm going to multiply everything, numerator and denominator, by the common denominator. Our common denominator is sine of x. So I'm going to multiply the numerator by sine of x and the denominator by sine of x. When I do that, 1 times sine of x is just going to be sine of x. And then in the denominator, by the way, I'm not changing anything, right? Sine of x times over sine of x is just 1. So I'm still multiplying by 1. Everything is still equivalent to the line above it. So when I multiply sine of x to 1 over sine of x, the sine of x's cancel, so I get a 1. And then when I multiply sine of x to negative cosine of x over sine of x, the sine of x's cancel here, so I get sine of negative cosine of x. And at this point in time, there's not a whole lot more I can do with the left-hand side, so I'm going to leave it as is, and now I'm going to deal with the right-hand side. So the right-hand side right here, we know is cotan of x plus cosecant of x. I'm going to do the same thing. I'm going to change everything here into sine and cosine. So this is going to be cosine of x over sine of x. That's what cotan of x is. And then cosecant of x is 1 over sine of x. So now I can put this all together into a single fraction. So I can say this is cosine of x plus 1 all over sine of x. So we've got our left-hand side, we've got our right-hand side. These fractions do not look the same, and I need them to be the same. I need to get to a point where I'm showing that the left side is definitely equal to the right side. So when I take a look at this right here, we know that we've got 1 minus cosine of x in the denominator here, and we've got sine of x in the denominator here. man, it would be really cool if I could have a sine of x in this denominator right here, right? I can't get a sine of x in this denominator here, but I can get a sine squared of x, because remember that if sine squared of x plus cosine squared of x equals 1, then we can say that sine squared of x is equal to 1 minus cosine squared of x. So if I can get this right here to say sine squared of x somehow, then one of these sine squareds is going to cancel out with one of these sines. And then I've got a common denominator of sine of x. And you might be like, well, that makes sense, fine, but how would I know how to do that? You just have to get creative with this a little bit. This gives us a clue that I somehow need a sine of x in that denominator, and the only way that I can do that is if I have a sine squared of x. Well, we know that this right here, like if I were to factor 1 minus cosine squared of x, that would be 1 plus cosine of x times 1 minus cosine of x, right? Like this is a difference of perfect squares. So when I factor 1 minus cosine squared of x, I get this. Interesting. I already have the 1 minus cosine of x right here. So I can multiply this by 1 plus cosine of x in the denominator, but whatever I do in the denominator, I also have to do in the numerator. This ends up becoming sine of x times 1 plus cosine of x all over this right here. When I expand this out, becomes 1 minus cosine squared of x. So now I can say that this would be sine of x times 1 plus cosine of x. And we know that sine squared of x is equal to 1 minus cosine squared of x. So I can replace this 1 minus cosine squared of x with sine squared x. And then lastly, all I have to do here is say that this sine of x right here goes away with one of these sines of x's. And then I end up getting right here 1 plus cosine of x all over sine of x. Left side equals right side. I'm good to go. I've done my proof. All right, and that's it for this. Let me know if you have any questions. Otherwise, I'll see you in class. We'll do great with the practice with this. Do not stress for 1 second. You'll get a lot of chances to practice this. All right, have a good day.